Today we're going to talk about a few operations on complex numbers in trig form. So let's say we had two complex numbers in trig form. Let's have z1 is 2 cis 2 pi over 3, and z2 is 8 cis 11 pi over 6. The way we multiply is we multiply the radii, so 2 times 8, and we add the angles, 2 pi over 3 plus 11 pi over 6. So z1 times z2 is 2 times 8 cis, the sum of the angles. So that's 16 cis. We get 4 pi over 6 plus 11 pi over 6. And that simplifies to be 5 pi over 2. And 5 pi over 2 is really coterminal with pi over 2. So this here is the product of z1 and z2. So once again, you multiply the radii, 2 times 18, and then you add the angles together. Okay, now for division. Let's have two complex numbers. We'll have z1 cosine of 300 plus I sine of 300, and z2 Now we can write this in cis form if we want. I just kind of feel like writing it out the long way for one of the problems. But if we divide z1 by z2, we do the opposite of what we do with multiplication. We're going to divide 24 divided by 8, and then we subtract the angles, 300 minus 75. So 24 divided by 8 plus I sine of 300 minus 75. So that turns out to be 3 cosine of 225 plus I sine of 225. So that's it for division. You divide the radii, subtract the angles. Okay, now for powers. Let's say we have 2 cis 2 pi over 3, and we'd like to raise that number to the 12th power. Well, that would be 2 cis 2 pi over 3 times 2 cis 2 pi over 3 times 2 cis 2 pi over 3, and we would keep multiplying until we had 12 terms here. So that means that we would multiply 2 times 2 times 2 times 2 12 times, which otherwise can be written as 2 to the 12th. And remember, with multiplication we add angles, so we'd have 2 pi over 3 plus 2 pi over 3 plus 2 pi over 3. We would do that 12 times. So it would be 12 times 2 pi over 3. So 2 to the 12th happens to be 4096 cis. Here, let's simplify. 3 into 12 is 4. We get 8 pi. And 8 pi is coterminal with 0, so I'm going to simplify that a little bit. 4096 cis 0. So we raised one complex number in trig form to the 12th and ended up with this complex number. And the way we did that was we took the radius, raised it to the exponent. Here we had 2 to the 12th. And then we multiplied the angle by the exponent. So we had 12 times 2 pi over 3. And that's how you find powers of complex numbers. This method or formula, where we raise the radius to the power and multiply the angle by the power, is called de Moivre's theorem. De Moivre was a French mathematician who lived in the late 1600s, early 1700s. But you'll see your textbook sometimes refers to de Moivre's theorem, and you want to know that they're referring to powers of complex numbers. And here is our summary. We already met complex numbers in trig form. Now we're operating them. Here, our first line is if you're multiplying two complex numbers in trig form, you find the product of the radii, and then you add the angles. Then if you divide two complex numbers in trig form, you divide the radii and subtract the angles. And then if you're looking for powers, this is to the nth power. I know that's hard to see. You raise the radius to the nth power, and then you multiply the angle by n. Now you are going to do some problems out of your textbook where they do not give you your numbers in trig form. So they're giving you the numbers in standard form. So you're going to see something like this, and then they'll ask you to raise that number to a power. What you need to do first is convert to trig form so that you can then use these formulas up here.